Hello. 6.2, it's some of the problems you should use Excel um just because you're going to do multiple calculations. So if you take a look at the notes for 6.2 exponential functions note, let me open it. It's a PDF file. I am about to go over the first two pages using Excel as calculator example number 1 and example number 2 in this video using Excel, okay? Because I'm going to really use my Excel as a calculator to figure out this entire table. I will stop the video after I go over those two examples and ask you to try my Math Lab Homework 6.2 number 1 through 4 using Excel as calculator. Just the same thing that I'm about to do on the first two problems, but I'll ask you to try 4 on your homework. Now, I will start another lesson on pages 3, 4, and 5, and these are probably easier for me to go over in a I'm probably just gonna write down notes on pages 3, 4, and 5. But what I did was I created separate Excel files for example number 1 and 2. So please download that and let's do that together, okay? So I'm gonna close this, and if you go back to the modules, sorry about Monday, I ended up posting like 3 short videos instead of 1 long video. I just keep on getting distracted when I was recording, but right now I know I'll be able to do example 1 and 2. Um, Take a look at this file. It says Math 161 section 6.2 example 1 and 2, and this is the Excel file that I'm going to use to go over example number 1 and 2. So just download it. It gives you a preview, but that's not what we're gonna use. I'm gonna go ahead and open this, and then this is the same thing that I actually typed up in Excel. But the original file was just a note. So if you want to just watch and write down the answers on that printed out notes, that's okay. I just didn't know how to type up a subscript, like it was Q naught, like Q of 0, but I just used this underscore. I hope that makes sense. But the first sheet is example 1, and then the second sheet is example 2. I'll go over these two examples in this video, okay? And they're going to be very similar to your homework 6.2, number 1 through 4. All right, example number 1. Consider the following case of exponential function. The population of a town with an initial population of 54,000, so that's the initial population, that grows at a rate of 7.5% per year. We're going to first create an exponential function, q, that tells the population given the year at t to model the situation described. So take a look. We're going to type up an equation together, something that you will just write on your paper. Q equals, the population equals, now Q naught. Now I use this notation, like Q with underscore and 0, but what you will see is, you're gonna see on my Math Lab as this notation. Let me just open this note one more time. I just couldn't type this notation on Excel. So Q naught, that means the initial population, okay? So what you're gonna do is you're gonna first multiply by the initial population times 1 plus the rate, and we're gonna raise that to the tth power. Okay, so Q equals, what's the initial population? Initial population is 54,000, and we're going to multiply this by 1 plus. Now, what's the rate? R stands for the rate here. The rate is 7.5%. In Excel, we can type in 7.5% if you want. 7.5%, and we will raise this to, and the button that I pressed is Shift number 6. When I did that on my keyboard, it gave me this caret button, or a key that will raise it to the exponent. And t is going to be the input variable. So that's the function. That's the function that you're going to write for this population model. Okay, so we're going to create a table using the value of the quantity Q for the first 10 years of growth. And we will round to the nearest whole number as needed. So what if it's year 0? What if it's year 0? Let me go ahead and type it the exact same formula down here, but I'm going to use t equals 0, okay? So look, I will type up equal sign. Oh, what was Q naught? The initial population was 54,000. Oh, I don't think I use comma. Oh, because the Excel may get upset if I use comma in my number. So I'll just use 54,000 times, sorry, that C15 label is bothering me. Okay, parenthesis 1 plus, the population is growing at what percent? 7.5%, right? So 7.5%, close the parenthesis and raise this to the year 0. But instead of typing 0, I'm going to click on this B16 and I hit enter. The population at year 0, well, the initial population is 54,000, right? Alrighty, what I did, guys, I formatted this table already for you before I uploaded on I posted it on Canvas. I just did it as a number with 0 decimal places because the rounding that we want to use is round to the nearest whole number. That's all I did, and I even clicked on this comma delineator. So this looks pretty nice. I can see that the population is 54,000 at year 0, the initial population. And what's awesome about Excel is I don't have to type up this formula over and over for the bottom. You know, because I'm using cell referencing B16, I can just go ahead and fill and drag this down, all the way down, and it's gonna find me the population for year, let's say t equals 5, and for year t equals 8. So why am I going over this problem? Because when you are doing your My Math Lab homework, let me show you My Math Lab. Going to your class, I think I'm not sure if I opened it already, but let me just go to assignment and show you why I'm going over these with you. My Math Lab homework 6.2. The first 4 problems, it goes like that. It's very similar to what we are doing. It doesn't show us the second part, but creating an equation with the initial population of 50,000. Let me do this real quick. 50,000. And the inside part is 1 plus the rate of 5.5%. 5.5%. But here's the thing. My Math Lab probably wants you to type in decimals here. So instead of 5.5%, I will do 0.055 raised to the teeth power. Now that part, we don't need Excel. I mean, we can just write the exponential equation, but then they're going to give you this. Now this is, if you do this individually, that's 1, 2, 3, 4, 5. That's 9 calculations that you're going to do by hand. And you understand why I'm just doing that, right? If I just use Excel and fill and drag this down, it's going to do the other calculation. So that's why I wanted you to use it, okay? All right, because all you have to do is you copy these numbers into your My Math Lab homework, and that's gonna be great. All right, let's graph this exponential function. This one will be asked as a multiple choice for you, but I can simply just select my table and I can go to insert. Hello, insert. I will go to recommended chart and just kind of want to have like a scatter with the line. So I can see that the population is growing, and it's not a straight line, right? This is an exponential curve function, so we'll see this little curve going on. But this is something that I copied and pasted on the PDF. But that's how I created this chart. Let's do one more. Let's do one more equation writing, and then filling out this table. Now in this example, we're looking at a average price of a home, and the average price of a home was $485,000 in 2007, but home prices are going what? Down by 1.25% per year. Now hold on. 1.25%. I'm sorry. 1.25% Just because I noticed that your Math Lab homework will ask you to type in a decimal, I'm gonna go ahead and just convert that into 0.0125. Okay, so that's the rate. That's the rate. But notice the prices are going down. So I'm not going to do 1 plus my rate. I'm going to do 1 minus that rate. Okay, so let's create the exponential function. Q equals, first you multiply by the initial amount. The home price was $485,000. But then we're going to multiply this by 1 minus, because the prices are going down. I would usually type in like 1.25%, but I noticed that on your homework, they're going to ask you to type in a decimal. So just simply divide that 1.25% by 100 to convert it into 0.0125, and we're going to raise it to the tth power, whatever that t is. T stands for the number of years since 2007, right? So that's the equation that you're going to give them. And maybe sometimes you're going to have to actually evaluate what's inside that parenthesis. So if you do 1 minus 0.0125, they may ask you to type in that 0.9875 instead of this subtraction, but they are the same thing, right? Alrighty, I'm ready to go ahead and fill out this table. The first one, I will just use the year 0, but then after that, I'll just copy this down, okay? So I say set it equal to 485,000. Oh, I forgot the equal sign. That's not what I want. 485,000 times, let's do 1 minus 0.0125, and we're going to raise this to the tth power, and the t that we want to use is in B16. I couldn't click on B16 because my text box was extended to the left. But I'm gonna do that, and I will take a look. And it says, yes, that's exactly what I want. And they're gonna ask you to round to the nearest whole number. So I'm gonna format this as currency with just no decimal places, a whole number. So that way I don't have to individually round all these answers. If I just format the first cell and copy the format down, then the rest of this table will be perfect. So if I copy this down, ta-da! Notice the price is going down. So when they say t equals 10, what do they mean by that? T equals 10 means 10 years after 2007. So this is the average price of a home in this town in 2017. And as you can see, it went down, right? So when we graph this, I grab enough all this table, and then I will go to insert, whoopsies, recommended table, and click on the scatter. You notice this chart is going down from left to right, right? So just like that, we can create a quick table, and then we can go ahead and graph it. Now I'm gonna do one more homework assignment with you, because that was just 2 examples that I showed you, but I know I'm gonna ask you to do 4 problems on your own. So not this one, maybe let me do just, I know 1, 2, 3, 4 are the similar types. Let me go over number 4 on this homework, okay? And I'll just do this with you. Consider the following case of the exponential growth. Your starting salary at a new job is $1,300 per month, and you get an annual raise of 5% per year. Now, we're going to go ahead and do 1 plus 0.05, right? Because it's a raise, it's gonna go up. But if nobody wants our salary to decrease, but if it's a case of like a decreasing, then you're gonna have to do 1 minus. Oopsies. Mark as red. My mom's wondering if I'm doing okay. Alrighty, how are you guys doing? I think I have seasonal allergy. Feels terrible, but okay. So I clicked on it. It says nice work. Now this is the part where I'm going to use the Excel, right? So take a look. I'm just gonna go bring up an Excel program. I'm gonna go ahead and maybe open up a third sheet so that I can make a table for this. I only have one screen, so I'm gonna go ahead and just like make it look like this, and just gonna copy down the year equals T. I'm gonna do salary per month, and I will do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, if I want to make it look more like a table, I can make it more like a table. But I'm just using this to do the calculation. So first one, I will do equal sign 1300 times 1 plus, I don't know if you can see it. Let me go ahead and zoom in. Maybe you can see better. All right, 1 plus 0.05 raised to the year next to this is 0. So if I hit enter, I get that the salary is, this cell is too big, 1300. And this is round to, how did they want you to round it? Round to 2 decimal places as needed. So what I'm going to do is I'm going to go ahead and make this cell, I'm going to format this cell so that it is rounded to 2 decimal places. So format, how do I format this? Hello, format cell, number, number with 2 decimal places. If I do that and then copy this down, I'll be able to get the rest of the numbers, right? My job is just to simply copy this down on this My Math Lab homework. So let me do that, and then I will click on check answer with you and feel happy. 1365.00. Next number, 1433.25, 1504.91. For year T equals 4, 1580.16. And number 5, 1659.17. And year 6, 1742.12. Almost done. 1829.23. 1920.69. 2016.73. And the last one is 2117.56. All right, I am done. Hopefully I didn't type any typo, but I'm ready to check my answer here. Check answer. Fantastic. So that's why I wanted to show you this, because if you don't use Excel, then you're just going to have to sit down and do, 9 individual computation. Well, you can, but it's much easier, right? Now, I'm going to go ahead and pick the most, choose the correct graph. I know how to graph this. I grab all the table. I go to insert. I will go to recommended chart, and I'm just going to click on this exponential or the scatter. Now, it's of course it's going up because it's salary. We want it to go up. Per month. What do you mean by per month? I had a typo. I should say for month. All right, salary per month is going up. So which one is going up from left to right over here? Oh my goodness, almost all of them, A, B, and C are all going up from left to right. But I know for sure D is not the answer. But now, the initial salary is in between 0 and 1,000 and 1,500. It should be at 1,300. So I'm going to go ahead and make each of these graphs go up big. Hey, you see the initial salary for this one is slightly over 600. That's not what we want. The initial salary should be in between. This may be it. It's above 1,200. Let me check the other one. Oh no, they look about the same. Well, the initials are for both B and C looks pretty good, but for me, now I'm gonna look at the 10th year. Year 10 should be around what? Year 10 should be around 2,117. 2,117, and as you can see on this graph that I just clicked on, is over 2,400, right? So I know for sure the correct graph must be B. Check answer. Fantastic. So the rest of the homework 5 through 8 are gonna go well with the PDF notes that I'm gonna record on my iPad, but hopefully what I just kind of did with you help you on number 1, 2, 3, and 4, filling out that giant table, choosing the correct graph. But I will be back with the other part, guys, right? So we just went over on this note. We just went over number 1, example 1, and example 2. I'm going to come back and do page 3, 4, and 5 shortly, okay? I'll see you later.